All right, let's wrap up the evidence for evolution lectures here. Again, just recapping, when we look at evolution, change in population over time, Darwin and Wallace both come to the same conclusion independently of each other, draw the same conclusion about natural selection, use that as the foundation for evolution. Presented to the Linnaean Society, critics then say, show us proof. So we talked about lines of evidence, things like the fossil record, anatomical evidence, biogeography, molecular evidence, genetics. All these different lines of evidence continue to support evolution and the theory of evolution. Critics still have objections, and as a biologist, you will have many conversations with folks over the years, and you will have to be able to address these criticisms. The first one that usually comes up is just a theory. What's your theory? What's your guess? Evolution is a theory. So is the germ theory. So is plate tectonics. These are all theories. But when used in science, theory is supported by facts. It's not a guess anymore. There are no intermediate fossils. Wrong. We have intermediate fossils. They're in the fossil record. We see evidence for them. Archaeopteryx. Look at the evolutionary history of the horse. Look at the evolutionary history of the whale. There's plenty of intermediates stacked in there. So the fossil record is continuing to be filled out. There's more and more data being added to it all the time. So there is enough evidence to say we do have intermediate fossils. We left off last time with life is too complex for natural processes. This can't happen naturally. It doesn't happen on its own. It's not something that just coincidentally occurs. And this is where this concept of intelligent design comes in. Intelligent design is a fascinating idea. It's a fascinating area of research right now. The concept is that there's some kind of designer out there crafting and manipulating life. For most folks, that translates into some type of spiritual being. When you get into spiritual, you're outside of science. So intelligent design is not an equivalent to a theory of evolution to say, well, life's too complex for natural processes, so that means intelligent design, some designer created it. That's not the case. We have plenty of natural explanations for these processes. Plenty of, here's how this changed to this, how this evolved to that, examples that show us you can have complexity through natural processes, through natural selection, through mutation, through genetic drift, through gene flow, through sexual selection. All those different things that drive evolution can create the natural processes and the natural world we see today. So intelligent design, again, is a really, really interesting field. I encourage you guys to look it up, get some more information and more background on it, but please keep in mind, since it cannot be tested scientifically, it doesn't go into the realm of science. The fourth criticism, evolution violates the second law of thermodynamics. Okay, so we talked about thermodynamics when we were talking about energy. Thinking or looking back, say, okay, first law of thermodynamics says we change energy, we convert it. Second law says during conversion, nothing's 100% efficient, and we lose a lot of that energy in the form of heat. Evolution doesn't violate it. It follows the second law of thermodynamics. As things change, as they evolve, they're following thermodynamics. Thermodynamics, it would violate it if we were in a closed system where there was never an input of energy. The Earth is not closed. It gets energy from the sun every single day of the year, every single day of the Earth's existence, energy has been coming in. So yes, energy on Earth is going towards entropy, or it is not 100% efficient, but we always have a supply of energy coming in. And that energy coming in is what helps drive life. And as life continues to reproduce and change and adapt, it continues to evolve. So it is not violating the second law of thermodynamics. And our fifth objection here. Scientists are working on all these things, and the fifth objection, people say proteins are too complex to happen naturally. You can't get proteins just by chance. They're too complex, they're too improbable. That this amino acid and that one and that one and that one and that one all combine to form this particular protein which does this job. They're arguing it backwards. Proteins are complex, but they can happen naturally. So the comparison would be to say, I look at a group of students and it is improbable that I will have students with birthdays on January 5th, 12th, 18th, February 3rd, 7th, 9th, and March 22nd. That's impossible. But I can look in my classroom and see that. You know, I could take the roster and look at the birth dates and say, okay, here's all the birth dates. Is it improbable that that could happen? No, it's not. It's not. So again, this is kind of the same argument as life's too complex to have happened naturally. It does. It does happen naturally. The sixth objection, and I've had this conversation with many folks, no one has ever created a frog from a fish. We've never been able to do this. Can't do it in the lab. I haven't seen it in front of my eyes, so it can't happen. It's not possible because I can't witness this and I can't recreate it. Well, amphibians did evolve from fish. They evolved from aquatic ancestors, the fish group. And because we haven't been able to repeat it in a laboratory, doesn't negate that it happens, that it occurred. So to look at why we think that fish evolved into amphibians, we can look at the diversity of fish out there, we can look at amphibians. This little guy up here is a mud skipper, not much different than some salamanders we have on Earth, some primitive, simple salamanders. So can we evolve a fish into a frog? Give me 1,000,000 years. I probably can do it, but that's not realistic. The critics often want to see this in front of their eyes today. Show it to me today. You have 1 hour for this experiment. Go do it. Let me watch it happen. It doesn't work that way. That's not how evolution works, and that's not how life works. So, yeah, they're right. No one has ever created a fish from a frog, but that's not a valid argument to say evolution doesn't work because I can't see you change this fish into the frog. Okay, the last one, we look at the last major criticism, the cellular organelles, or the cellular machinery, cannot be explained by evolution from simpler stages. So you can't explain the mitochondria from these little stages of development or evolution. You can't explain the flagella in the bacteria, something that changed in increments to create the flagella. It's too complex. So there's some books written about a thing called irreducible complexity. There's counter books called The Blind Watchmaker. I would strongly encourage you guys, look at the basics of these to get a better feel for this. But one of the arguments is the complexity of our organelles could not have developed or evolved through simple processes in these simple stages. So the flagella on the bacteria always has to be a flagella. It always has to have been just the flagella and never anything else. So they're saying, oh yeah, you can't get complexity through natural selection. Well, that's wrong. You can. Flagellas can work in a simpler fashion as different structures. And then it's the combination of these different structures that then leads towards the complexity of the structure of the flagella. So organelles can have evolved from simpler stages. So again, I'd encourage you guys to take a look at some of those other resources out there, and they go into a lot more detail, a lot more thorough, much deeper explanation towards why these criticisms do not hold up against the evolutionary theory. So again, wrapping this up, there are plenty of lines of evidence. Make sure you're comfortable with those lines and examples of those lines of evidence that support the evolutionary theory. Theory is something that is supported in science. It's not a guess. It's not a maybe. It is something that we support through science and the scientific method. So make sure you're comfortable with this. This is a core foundational topic for this course. This is a core foundational topic for all of biology. Again, no matter what field you go into, I'm going to go into conservation, I'm going to go into pharmacy, I'm going to go into being a doctor, I'm going to go work for EPA, etc. Evolution is what's going to be your foundational concept to do all of those jobs. So we have to understand it. We may not agree with it, we may not like it, that's fine, but you have to understand it to be able to use it.